All right, this is a refresher on the Edgenuity lesson, Solving Systems, Introduction to Linear Combination. Oops. So at the beginning of the video, they talk a lot about additive inverses. All that means when you have additive inverses is that when you add them together, they cancel each other out. So for example, if you did 12y plus negative 12y, they cancel out. Similarly, if you did negative 4x plus 4x, they're going to cancel out. So the reason we want this is when you have an x and a y in an equation, you can't solve it and like solve x and get a number value and solve y and get a number value because they're not like terms and you'll never be able to put them together. So what we can do to solve a system where we have two different variables is we can use linear combination, which means we add the equations, and what we want to happen is when we do that, one of the variables just cancels out completely. So on this one here, if we add it the way it looks right now, will anything cancel out? Answer to that is yes. So if we add vertically, 4x plus 2x, that's 6x. 3y plus negative 3y cancels out. They're opposites of each other, additive inverses. 16 plus 8 is 24. So now we have an equation. I'm just going to scoot it closer. With just one variable, we can solve that. Divide both sides by 6. So x is 4 on this one. Now, like I've talked about in the other videos, when you're solving systems of equations, remember these are all equations of lines. So the solution is where the lines intersect at an ordered pair. So just because we have the x coordinate doesn't mean we're done. We have to go back and get the y coordinate. You can plug it into either equation. It doesn't matter. I'll go ahead and plug it into just the top equation for no reason. So 4x, which we know is 4, plus 3y equals 16. So we got to multiply this first. So 16 plus 3y equals 16. Subtract 16 from both sides. So we got 0 on the right, and then divide by 3. Okay, and we write our solution as an ordered pair. So the solution to this system of equations is 4, 0. So now let's look at this next one. If we add these equations exactly the way they looked right now, would anything cancel out? The answer to this one is no, because if we add, this will be 7x, y minus 2y, that's going to be negative y, and then we'll end up with 25. So none of the variables are going to cancel out. So what we can do is we can multiply an entire equation so that you have additive inverses. You can choose to cancel out the x's, you can choose to cancel out the y's. When I look at this one, it looks like it's going to be easier to cancel out the y's because this is just a positive y. So if this one down here is negative 2, we need this one to be a positive 2y so that when we add them, they cancel. So I'm going to multiply the entire top equation, all 3 parts, by 2. So we end up with 6x plus 2y equals 10. The bottom, we don't have to change at all. Like so. Okay, so now when we add them, 6x plus 4x is 10x. 2y plus negative 2y cancels. And 10 plus 20 is 30. So I'll just move those closer. You don't have to do that step. Now to get x by itself, I just divide both sides by 10. And we get that x is 3. Now, you can choose to plug this into any of the equations, even the one we changed. I wouldn't recommend doing that because all of these numbers are bigger. So I'm going to go ahead and just use my original one with the small numbers here. So 3 times x, which we know is 3, plus y, we're trying to figure out, equals 5. So the solution to this system is 3, negative 4. There are going to be times where you're going to have to multiply both equations, things that match up. So just really quickly, I won't do the whole thing. But one example of that is if I had Okay, so like on this one, if we add them the way they look right now, nothing's going to cancel out, so we've got to change them. But there's nothing that we can multiply a whole number integer to get those to cancel out. So what I would do is I would find the least common multiple of this 3 and 4, because they're already opposites of each other, and that would be 12. So for these to work, this needs to be a positive 12x and this needs to be a negative 12x. So the top equation we'd multiply by 4. The bottom equation we'd multiply by negative 3. So in the top it would then become 12x plus 20y equals 24. And in the denominator, I don't know why I did a negative 3. I meant just multiplying by 3. When we multiply negative 4x by 3, that's negative 12x. 2y times 3 is 6y. And 5 times 3 is 15. Now when we add them, those x's will cancel out.